So I don't know how groundbreaking all this is going to be. I suspect people are doing some of these sorts of things. I guess I kind of wanted to share my experience of what the delivery team has been doing and really kind of, I'll quote Srini again, this kind of a situation where we're in a way felt like we were maybe building the plane while we're trying to fly it. So trying to get people on the team that are looking at statistics and pulling in data and thinking about what things we're going to report to the government agencies we're supporting, doing decision support for and things like that, and trying to put those into products that are things that can be put into presentations for people. When I came into this, I think the role people were looking for me is to try to maybe, it's kind of a vague term to say automate or to make things streamline, put them into production mode or something like that. But initially, I went in helping to just simply build a packaging script, like some of the artifacts that people were going to send off to the agencies. Just basically getting the things together from patch sim and other outputs into a zip file. Basically, it was just as simple as that. So. But then it kind of evolved into other things that I could fill in and help with, like, so the main thing I think Srini and Brian and others were thinking as every day they're going in and pulling data from different sources, and the number of sources was adding up. And so thinking about a way just to have that happen every day automatically. And so that this concept of people at various levels and various points in development, their tools and things in various points of development kind of coming together in this common workspace, right? So the simple idea was just to create a folder on Ravana, our cluster, right? And I called it this COVID Commons workspace. So this is where it is, lives on Ravana. Then that basic idea was just to start off having a place where people could maybe share data. I pulled in some of our efforts in terms of our GitHub repositories, the dashboard. I pulled in that repo, and a main thing that the team is working in is this spread modeling. So Srini's PatSim tool and the statistical analyses of some of the data sets that are coming in. Shemek is doing heavy work and working on this under this adaptive modeling thing, which I'm not going to go into today. I'm not as familiar with some of the other efforts, but the two things, I guess, are the common workspace kind of came together for me is in terms of the data, right? All the data things that we're pulling in. But then I also, as soon as the data comes in, people want to do some processing on it and use it, right? And there are people coordinating, hey, can you do this? Students and postdocs and people, are taking on different parts of this effort. And I was thinking, if I want to transition that into something that can happen every day and be a little bit robust, I'd like to have some common dependencies. So my thought was to have a singularity image. So basically, I think people know what singularity images are, but they're basically dependencies and programs and things of basically a large chunk of an operating system, right? Except for the kernel and other things. So you can kind of package things that work together that are the right versions and things into one place. And people use Anaconda, and that works for things like this also, Conda and the Conda tools. But I like to have this kind of a complete sort of package idea. Okay, so basically, I just went through and looked at people's notebooks and their scripts, and mainly I just looked at their import statements for their Python scripts, right? And said, okay, these are all the Python modules people are using. I'm gonna put all these things in this image. There's some people were using an older R package for a particular tool, and there's some other things like Image Magic people were using, but I tried to put a bunch of things into this so that they were available. And the idea was that once they were ready to run these every day, then I could just use this as the environment to run those things. I wouldn't maybe have to deal with, they're using this version of this module or whatever. And so let's see. So it's a common workspace, common tool environment. I tried to develop these things to make them sort of modular. So if parts can be used in other places and things like that. One of the themes, I guess, with this sort of, my idea is trying to use patterns between light and heavy, things that don't necessarily lock you into a particular system, just use some things that can standardize things, but maybe not I don't know. I guess it's hard to explain, but maybe you'll get the idea as I go on with this. These other things I'm going to kind of go into after this main idea. But so here's basically the things that are in this commons. And I guess I did kind of go through some of this. So the motivation was many of the data pulls were big and time consuming and they needed to happen every day, right? Some of the things we were doing, not only just pulling data and using it as things were going on. And I know from working with Bowen before, he had to deal with things like where time points from previous data sets were updated and so-called backfill and things like that. It wasn't just a matter of pulling in the data and then getting the data for the new date and adding it to the other dates. You had to go back and kind of check to see if the history of what we're using for time courses basically has changed. So this is one thing I tried to handle with them. I'll go into what I made, these data repos, and we'll see if that's necessarily a good idea or not. I wanted to reduce some of the redundancy in the pull and process effort, so people having their scripts maybe having less redundancy in terms of what they typically do. If they all typically do certain types of cleaning and certain types of processing, maybe I could centralize that and get that redundancy out of those scripts for them. So here's kind of a view of the data part. So pulling in the data, right? These are all the different things that we're pulling in every day. Some of these only fire every week, but a lot of these things are happening every day. These are scripts, basically. People are familiar with Slurm. These are basically wrappers that are running other scripts that are pulling the data, and some of them are doing things like snapshotting. So, and then some of these are doing some preliminary processing in terms of just generating just quick plots that people, as soon as the data comes in, it'll generate a plot so people can get an idea of what to do next with some of these things, or some of the typical things they want to look at as soon as you get the data. So these are also kind of included in this data part of this repository. And I guess maybe I'll mention, by the way, these are all GitHub repos, and this is also a GitHub repo. It's not named like the GitHub repo because at first I just wanted this to kind of be the place where the data was, but then I added the scripts that are handling data in there. I think it probably should be separated out, but for now, I think it's fine. Typically, the ones that are fetched are just basically grabbing data and clobbering the data that's in there, more or less. Most of them are just doing that. I've tried to evolve some of these into these update things where they do kind of try to handle having snapshots of the data, right? But a lot of these are still things where basically we're having data directories and then creating a new data directory and then putting the things in there. And a lot of those end up becoming redundant with the previous data directory, a lot of the data things. So that's one of the things I try to change with these Git data repos. I'll try to go into that a little bit. So for the daily, as far as what's going on with the data related things, this is kind of the master script that's firing all this stuff off. It's basically, it runs a little bit after midnight, and then it does an S batch with a particular time that certain things go off, and they'll go off at odd times. I didn't want them all to be hitting servers and doing things all at once. And some data sets tend to update at certain times, so we wanted them to update. Some of these things also in this daily script here are also dependencies on other things. For example, we might have the plotting that will only happen after a particular data set. I guess I'm going to call these data collections. Most of the time, they're just tabular data, CSVs, and folders. Some of these things are the fire at a certain time, and then other things might actually be dependent on certain things. So this is kind of the daily grind of the data as far as the delivery team. So the pattern for these S batch scripts is, I guess I think of this as basically they're adapting things to Ravana. So not only are they doing the typical S batch things, right? Basically having these wrappers that S batch scripts, typically just shell scripts. They don't necessarily have to be a shell script, but typically they're a shell script with some additional comments in there that Slurm can use to figure out what resources what nodes and what places to run these things, right? But in addition to that, I'm using this to kind of fold in this singularity. So try to execute these things in this singularity environment. And then they also are doing things like handling, again, these are all kind of under the theme of making things work in this environment, on this particular cluster. So handle group permissions. It's been kind of an issue on Ravana with making sure that things that people are collaborating on are group writable. If you do a pull or run something that creates a file that writes something, updates something, and then by default, that won't be writable by another user. And sometimes we want to have that where two people can work on the same, more than one person can work on the same thing. And in this, it's been a little bit found it's not, things are ignoring the UMask. Some of the typical things you do aren't always working in all cases. So these scripts are also handling that sort of thing. Some of the artifacts that are using this pattern where they have data directories, one way to make that a little bit less of a burden on the scripts that are using that is just having a symlink that they can say, okay, I need to go to the latest version of this data. And if I want to do that, I'll just use this so-called latest symlink, right? So this script might do something like update that symlink to point to the most recent data pull. So that's things like that are going on. So these will then wrap Python scripts or shell scripts and these notebooks that run some of this stuff. That's what these wrap. And here's, I guess, one example. I don't know, but basically this is kind of what they look like. When we're running these, I want to have a place to figure out if something went wrong with them. So we output them to this, so output logs, and we can set this here wherever those go. My pattern has been to make this the same name as the SBatch file. And then, of course, people probably know that in this case, the job ID will be put here. I think this is technically the array ID, but in the case of these scripts, it'll end up being the job ID. So you can see, look in this folder, and you can sort them by time and see if things, went right. You can inspect, if things had gone wrong. So I've gone through and kind of fixed these to have a pattern, something like this, where you can go in here and if we want to maybe adapt this to a different environment, say, another cluster, right? Then we could change this up here and it would, I think, mostly work. Here's the part of this that makes the common work environment tool, right? We run Singularity, and I've had issues where some things didn't quite work unless I made sure I bound these in. Don't know if it's always completely necessary. This explicitly gives access to certain paths in that system. So this is that Singularity file that's got the environment, that's got, everything but the kitchen sink in there to run whatever tools people needed to use to run their stuff. And then that'll run a script like this, right? The update Python script. I'll typically also have that script accept optionally an input. So the data input location will go in here. This is maybe a little bit overkill, but this is the point we got to with some of the permissions issues. Basically, this was the thing that's changing the group permissions. And ultimately, I just wanted to get to this, the changing group permissions thing, but this is a way to parameterize it, to only change them in that location. You're not going to be allowed to run any of this unless you own the file. So it's not going to work unless my user. So only do it if it's a file that's owned by me. So it's just not going to work. You don't want to change the group permissions for things down in the Git objects. That's not appropriate for there. And this was a little bit to try to parallelize this, but it's not probably worth it. This is just quickly just to say that we have these Git repos are in group right configuration. All this is just basically showing that this is a shared repository. So when people go into these repositories, if they want to update things and pull things and stuff, you won't get errors because typically the default is to have the repository, only the files that are pulled and things to be not writable by the group. Part of this presentation is also kind of a bit meta in that I'm using this to also maybe show a way that we might use these notebooks maybe to both document and run things and maybe to do workflows and things like that. But part of it was an experiment to see how this using a notebook to both present and dynamically maybe do some things. So I might reveal some of these code cells that are, these aren't too earth-shattering, but these notebooks can not only run a kernel like Python or Julia or other programming languages, but they take advantage of this IPython shell, which has things where you can have access to the bash shell and things like that. These notebooks in Python tend to be a pretty good glue for putting different tools together. Here's one way you can put these repositories in a shared whatever configuration with the shared repository group. You can go through and do the git config. You can go through and edit this file, even if you feel confident in that, but that's just kind of a way. I'll show later why I tend to set this decorate. I guess this is a little bit more detail on that Singularity image. Currently, I have this COVID-19 work, and this is the production one. It's based off of CentOS 7. CentOS 7 tends to be a good base thing to work on because most things will be backwards compatible down to something as solid as like a CentOS 7, which is based off of Red Hat, and it's a good production thing to base things on. I wanted to have some newer libraries and newer things. I've started experimenting with using this Singularity image based on OpenSUSE Tumbleweed, which people would consider a kind of an edge, maybe not stable system. But the Tumbleweed distribution it's a rolling release, so you can just continually get updates. But it is tested, so it's not maybe the same thing as a Fedora or whatever distribution might be the cutting edge of something that might not be as stable. So I've been testing this out, and so far it's been kind of working. I just wanted to get some of the newer available things in and see if that would work. So that's another thing I've been trying. So again, these this environment collect tools in one place. Okay, so one interesting thing with this is, I think I did maybe mention this, that I can use that to do the production things. And people in the group can also then take advantage of this. For example, if they go into Ravana portal and open up a Jupyter Lab session there, and people probably have used these before. When you go into the regular lab session, you can see a bunch of just different kernels, right? If you go through, and I think I'll just open this. There's a way to use Singularity images as a kernel that will show up as available in your Jupyter Lab session. So, and this is what people have done for the delivery team. Here's the manual way. I think this would work doing something more automated like this, but basically they'll put a couple files down into this local share folder, Jupyter kernels on Ravana, and add an init file and another file. And basically then they'll have this available. And what I like about that, what's useful about that for me, is then they can use the tools that I'm going to be then using for production. If there's something that's not in this image yet that they want another module or something they want to play with or try out, they can still install that or use a different kernel and install that in their user installation or whatever. But they can shift over to this to see if that new thing has gotten into this kernel. They can test it out to make sure it works before we put things into so-called production. So this tool environment, I feel like, in a way, it's not as a fancy version of, people might be familiar with the Lunar Lander from the IGCAT server and the FunchyCat project. Andrew and Dustin, many people were involved in that. The concept was to package tools and a bunch of different things into something that people could then take and use on wherever in their laptop and out into the field and sort of thing. And that seemed maybe more elegant and portable and in a lot of ways more sophisticated. But my situation here, I feel like it's more like a construction trailer. It's just something you plop on a job site. It's got a bunch of the stuff that you use, and might maybe stay there for a while, So I guess that's, I don't know, my cute little thought there. But this notebook is also kind of serving the purpose. The idea is to have it serve the purpose of documenting some of the COVID delivery team efforts, right? And so this is going to live in the COVID Commons, and people can add to it and things like that. So, and one of the asks was that, you can imagine, so people want to know what things are running when, and so this is just one output of that. That's just basically looking through these SBatch scripts. It's a little bit crude and kind of depends on having this shell variable. But these are basically lines from the schedule daily data shell file. So they're basically pulling out lines from here that have to do with pulling, and it's just fetch and updates and pulling out where the batch script passes. Basically, the idea is just to get a quick idea about what things are running every day. I mean, that's basically what this is. So, and it's a dynamic way to generate that. So I've been encouraging people that are creating new tools and scripts and notebooks, if they want to put those into production, they can go ahead and look into this file and see the pattern for how I've been doing it, and then add things to this file if they feel comfortable putting their own things into so-called production, right? So if that happens without me knowing it, I like the idea of this notebook documentation thing being a bit dynamic. So this will go through and find that if somebody does that, I don't have to go through and update this documentation and say, okay, hey, now this is another thing that's being used. So I like the dynamic part of this. Here's another just a kind of a metadata sort of thing where people want to know, what are the data collections we're pulling? So this notebook is basically going through those update and fetch SBatch files. They're relying on this data location shell variable that I put in here, and they're using that to go through and find out what are the data collections that we have. It outputs this basically. So, and again, if somebody says, hey, and this has been, kind of a pattern, somebody say, hey, there's this new data set, or this data set is better than this other data set, or we've been transitioning from following cases and death rates and things like that to ultimately looking at vaccine availability. And then maybe you want to look at people that don't want to take the vaccine or whatever. And there's different data sets that come available, and some data sets, higher quality data sets, come available. So people say, hey, can we start pulling this regularly? So this is kind of a dynamic way to keep up with maybe what sets we're pulling, right? And then, of course, one of the next questions is, so what scripts are working with the data, right? Again, I like the dynamic part of this where we don't have to go and update this documentation to say, oh, hey, this script is now using data. So, of course, this is useful to figure out for a number of reasons. If people kind of experiment in their notebooks, their Jupyter notebooks, and do things, maybe we want to know what data sets aren't being used anymore, or we might want to, if we bring somebody new into the group, they might want to get oriented here and say, okay, well, what are some people doing with these data sets? What are the scripts that are using some of these data sets? So they might want to go and I want to do something with this data set, and what are some of the scripts that are going to be used? What notebooks can I go look at to get examples of what we can do and what people are doing? So, and another thing I do kind of like about these notebooks is you can pull in things from the shell, don't have to use Python for everything, right? And some things I think Henning had mentioned to me once, some things are just simply easier to do in regular executables that might be available via bash. So one thing that I found handy over the years is the find utility, right? So I'm basically wrapping the find utility here. And here, I guess here's an example. I'm using this SH module that can kind of wrap shell things. I don't know if this is detail people don't necessarily want. I guess I find it to be useful in general. Ultimately, what this is trying to do is going to find what scripts we have. So it's going to find files that have code that can be run. So these Jupyter notebooks and Python files and shell scripts, right? And people can add things to this to go find. This prune part is a find utility sort of thing. I basically don't want to waste time by descending down into directories that we're not interested in. A key thing is these IPy notebook checkpoints. They generate lots of these notebook files that are just basically kind of snapshotting, and it's not necessary. So this is a way to not search those, right? So that's being used to find scripts. This is to get script text. Basically, so my original thought was then to use grep, another shell utility. And that was getting to be slow. And I think probably because each time you run grep, it's going to open the file and load it. And I was having to do this for the same files repeatedly, because basically what I want to do is search for all these scripts to find out what ones are using what data sets. So each script, I wanted to try to search for any of these things. So this is just basically a function that's doing that. It has to handle the IPython, the Jupyter notebooks. I wanted it to handle them a little bit specially because only some of the code that's going to be actually accessing these data scripts. So basically it's going down into the code cells and finding the text there. Here I'm just pre-compiling some regular expressions to search, to make the searching faster. And then it's going to go through and figure out, what's in those. So the payoff here, this is basically the reporting part of this. You can see here, even when we skip all those other places where scripts are, we're still coming up with 549 scripts. I'm sure there's some other pruning. And I guess I should mention that find, this is basically a blacklist strategy, right? You're saying what you don't want to do, right? You don't want to go down into here. And we could instead pass in what we do want to look at, but I kind of wanted this to default to us not having to go through and add things to make sure that good search is there. So I want the default to be, it's going to try to find more things than we need. And then if it gets annoying to find things that we don't really care about, then we can add things to this prune. That makes sense. But there's a lot of scripts. So some of these things are of varying use. For example, this reports out that it found scripts that had this text in there, right? The Helix COVID-19 DB. So it reports out what script it was, and then the line in the script that had that. It does look like this would be one of interest. So typically, this is Python pandas reading the CSV file in to do something with it. So that's something legitimately, yeah, that's using that data. So we can go to that and see how it's using the data, or we can decide, hey, that's a script we're not using anymore. So that's one thing we could shut off or whatever. And eventually, if there's nothing using some of this data, we might consider not pulling that or not doing some of the things regarding that data, right? So this will go through and find things that are using. And some of these, let's see. Yeah, so this is not one that's using data. This is also going to reveal some of the updating scripts, right? But that's also, I think, not a bad thing. It's going to also look in that schedule. It'll find things in that scheduler. It's going to tend, I think, find more things than maybe are appropriate or necessary. So we can cut things down, but there's quite a few things. So one thing that it's been kind of an interesting thing. So we've got these data collections, and like I mentioned, they're collections of CSV files. I should mention that we're taking advantage also of APIs that aren't necessarily some of the things that we're pulling JSON, which is kind of nice because it gives you a little bit more information, more metadata, and some more structure that can be helpful. But most of the things are still these CSV files. And again, one pattern that was happening with the group was to have these data directories. So in general, I felt like that was maybe a little bit, for one thing, it seemed like a little bit inefficient as far as space, because there's a lot of redundancy between, CSVs between things, like the same file in directories of different dates, if that makes sense. There's definitely things that we have in our group that are using much more space than this. So that's not really a huge issue. And you can have deduplication on the file system, and you can have compression in the file system. So there's ways you can deal with that. That part's not a huge deal. I guess part of it is just the idea that there are things that look the same, but they're different. And just thinking in terms of coding, that's something you just typically don't want to have, is redundant copies of things that you have to maybe figure out, or track, or deal with. So, and another thought was that all the scripts that are using the data, often many of them, they'll either have to rely on this latest, making sure that we have to make sure there's a latest symlink pointing to the right directory. So they'll use that, and that's fine. Some of them would go through and that would figure out, what's the latest date, or what's the date that I want, and that's okay too. But I kind of like the default case to be whatever is just in the collection to be the latest. And I thought a nice way to do this would maybe to both have some sort of archiving-ish thing, also have some way to kind of look at backfill, or to check out differences in backfill or changes to the history that I think I mentioned before. But also then the default in the so-called Git working directory, the file that you actually want to use ends up being the latest one. So some of these puller scripts are using these so-called data repositories that I'm talking about here. People that have known me might assume that Git's one of my hammers, right? It's one of the things I try to use for everything. And maybe to some extent that's true, but it's not the best thing for everything. But in some ways, for these CSV files, it's maybe even better use case than source code, because a lot of these things, mostly what's happening is you're adding another line for another day, right? And that's kind of how Git stores and tracks the differences between snapshots, right? It's line by line, so they're line atomic. If something changed on a line, it's a different thing as far as Git's concerned. So if you change one character on a line, it will show that this line has completely been replaced by this other line with this character. So, and that's kind of what's happening with these CSV files. So I guess I kind of like this as maybe a strategy for keeping track of these. If people want to go through and look at the differences across files from different places, right? This is just an example of one of our data collections that's these so-called Git data repos. I mean, they're just lightweight, small Git repos, basically. Not all the files that are inside that so-called working directory, right, need to be tracked. So even if there was things that people were working on or trying out, they can coexist in there just fine. The things that are definitely being tracked is this county CSV, the state CSV, and this is something that I've auto-generated with the script, a README. I think I showed that Git configuration, that log decorate. One thing I like about it is it shows these tags, which are state scripts I'm having generate. It's just a quick way This is kind of my way of having the dated directories idea, right? You can go through and look through a history and find the commit and say when it happened to try to figure out when that pull happened. But I'm using lightweight tags here, not the ones that are actually baked into the repository. These are just basically references that just a file that says, hey, when I put this in here, it should refer to this commit. So we can replace something like this with a directory if we do want to go inspect something, the state of the data for a particular file in a past. I don't know if it was a side effect of this too, is it's interesting, like all these tags, right? So every day I'll update the tag, and if the tag is happening, it'll generate a tag that's for the current date. And if we do another pull in the same data, it advances the tag to the next commit if there was an update in the same day. But then you see some of these things pile up, which is in a way messy, but in a way nice, because you can just quickly inspect and say, okay, well, nothing changed for all these dates. In this data set, nothing changed. You don't have to go through and say, you don't have to go through and compare the files and look into them, right? You can just from looking at this, you can say that this data didn't change. I have my script automatically reporting itself that it's the thing that made this commit, right? So it adds the commit message. So some of this pattern is that there's this production thing that's going on here, but you can still go into these repos if you see something you want to add or something you want to change or fix or whatever. People can still go in them and manually add their own commits. You have the commit with your own commit message, but then you also see these commit messages. So I like that idea that you can have kind of ad hoc and manual things going on at the same time as automated things. Here's an example of what you can do instead of maybe looking at a difference between files on the file system. You can do a Git Diff of, so this thing, I think it's called the commitish. I think that means it's something that's like a commit. You can use a tag, you can use a branch name, or you can put the actual commit hash here. But basically this is saying, I want to look at the difference between something that happened at this tag, at a commit that's tagged at this point, and the commit that's tagged at this point. So basically, I want to look at what changed between the April 15th and 16th for this file, right? And if you want to pull out that file to redirect it into a temporary file, you can do a git show and then do just one of these, right? And then do the file redirection to a file. So it's a way that if you want to get at the other data, it's easy, but it's also kind of compacted. So if you run the git garbage collect git gc thing, you can get it fairly compact. So it's almost like having a gzipped file in there next to its working file, right? It's uncompressed version, the latest version. So another strategy would be for some of these things, if they're getting bigger, we don't want to see all the things we're not using, or we want to use less space or whatever. One strategy would be to just have the script add things to a tar gzip file or something like that, right? So this, I guess, I like this strategy that it gives you a little bit of both. You have something that's sort of archived, but also something that's, in the working state too, and it's together and it's in a form that you can easily find the differences without having to go through too much manual effort. So that's my thought there. I guess I'm getting to the thing that initially kind of sparked my thoughts about asking the software team. And I guess I want to say that all this stuff is in progress, and I feel like some of this stuff might not be that new to anybody to use these things. I know Stefan and other people are regularly doing things like this, more sophisticated things. So I just want to mention that any of this stuff is trashable. Like maybe we want to use some of the concepts from this, maybe we don't want to do any of this sort of thing. This is just kind of what I've maybe fell into starting to do when I joined the delivery team. And we might want to replace some of this stuff with what SciDuct will do, for example, and other things. So this is not a prescription for how we should do things. This is just kind of an idea. This is what I've been doing as far as this group effort, and does it work? So one of the thoughts I've been having, instead of maybe storing things in CSV files, was to have these collections be SQLite databases. So that's why I kind of changed the name to collections, because in this case, not everything is going to be a folder, right? If we start going down this road. And they really are kind of collections of files that come from whatever source. Sometimes there's only one file, but oftentimes there's multiple files that come from some of these data sources. The thought here is not the idea of having a full relational RDBM, relational database management system with its server and user and having it handle user authentication and things like that. That basically I'm looking at this as just a data container. So a file on disk that's got data, a data collection in a form that's maybe easy to look up, easy to connect together. So that was my initial thought with this. And I know that in some ways this is alternative in a way to like a pandas strategy. Pandas, is a Python tool that works with tabular data, right? And databases use SQL, right? And that's kind of two different APIs basically to work with tabular data. I'm not saying to switch over to using SQL necessarily, right? Or really at all. I'm just looking at this as maybe as a good form to store data on disk. This little bit here is just to show that the people that are using pandas and doing read CSV and writing out to CSV files wouldn't have to really add that much, and you wouldn't really have to even necessarily know any SQL. So this is one of the things I've been testing out. This is one of the updaters that's happening in parallel with the regular CodeCast folder system, right? Basically, you figure out what the database file path is. You connect to it, and then in terms of, this is for the thing that's pulling data and loading a database, right? You just use this pandas data frame function that's to SQL. You put the table name in, you have the database connection. This is basically the equivalent of the file name, right? In this case, I want to clobber the old stuff. You might not necessarily want to do that. You can append things and don't want to. Pandas has an index that's useful for pandas things, but it's not necessarily useful for database tables. So we don't want to put the index in there. So that's the point here, is to say it wouldn't have to be that hard, and you wouldn't have to necessarily know any SQL. To do the reading of them, there's this read SQL table, and I'll just quickly go to this link. But again, you wouldn't have to know any SQL, depart from the typical workflow of using the pandas API for manipulating and joining and filtering and tabular data. So you can use the table name and the connection, really, is what you would need to do that. So that's my thought with that. One of the ideas was kind of a data cache, I guess. And I know Dustin and Stefan had already even independently been kind of looking into this as a way for jobs, and I think the job service and such to maybe pass data around between workers and things like that, I believe. So it's not anything anybody hasn't already been thinking about leveraging this, I guess, for things. So, but one thing I guess I like about this in terms of the cluster, obviously, it's the form of the data. It's not text, right? It's got some kind of form that's already going to be nice for doing processing on. But you can set indexes on things to make some of the common operations that you want to do faster and things like that. It can be an issue accessing files on clusters, right? They're not necessarily on the same node or connected or whatever. So the more separate file systems operations you might be doing to open and read in different CSVs, it could be nice to just get a connection to one file and then just maintain that connection to do basically what you would be doing instead of reading separate CSV files. One neat thing, I guess, and I know Mandy and others have talked about using this, many people who've talked about using the sort of thing, would be to create views. So the idea would be to maybe have updaters would be the main things that would maybe modify the so-called base tables, the tables that are actually data tables, real data tables in database. And then if people wanted to have intermediates, typically the things you'd see people, reading a CSV file in and then writing out some intermediate file they want to use later or to use for a next step, you could maybe put some of that processing into a view, which is basically is SQL instantiated into a table name sort of thing. You have a SQL process that might do a join, might rename some columns, might filter out some things, right? But basically, you can then, once that view is created, you can access that as if it's a table, but it's not an actual real base table. In terms of working in this group environment, I like the idea of it can be ad hoc. It would be safe for people to create their own views. And they can also, other people can use the views that other people create. And I like the idea that it wouldn't affect the base data, because those views are read-only. So I like that idea. some of those batch files were running shell scripts and Python scripts. That most of those I've adapted from what people were using before. They're not notebooks, right? One thought, and one thing we've done for a couple of things is basically I've used I guess a farm to table analogy where we're harvesting data and doing something with it and then trying to deliver something to somebody, right? And trying to maybe make some of the things more direct. When I first came into the team, I was thinking, okay, a good pattern would be to turn some of these notebooks into command line scripts, right? So we refactor them a little bit and get people to maybe do some things in the notebooks that can make that process go easier. That seemed like a good thing, right? But if you're working in a fast-paced environment, you're asking students and people to effectively prototyping some things, but getting something where that it'll produce an output, a plot, or process some things, right? That can be a big ask if you're under a time crunch. So one thing I've done for a couple of the scripts has been kind of neat is just directly running the notebook and then having that produce the outputs. So this is an example of one of the SBatch type scripts. Is similar to the wrapper script that I've shown before, but instead of running a Python file, it's executing a notebook. So in this case, I'm testing out this newer version of the SIF, but the key thing here is when this is happening, it's running all these things as if it's running in an operating system that's like the Singularity Image, right? So in there, it's got the Jupyter and it's got the NB convert subcommand or module that it uses. But what's happening here is this is typically used for converting notebooks to, say, PDFs or HTML or whatever, and Python. You can use it to convert them to Python modules, Python files, right? So that's its normal job. But you can also have it, while it's in the course of doing that, execute the notebook, right? And here's a directive that's to say what the output should be. So the output that we're interested in is really a side effect of the notebook, right? It's whatever the notebook's doing, the files and things it's generating. When these notebooks run, right, they update the cells, the output cells in the notebook, right, basically. So what this will do is output its stuff to a notebook. And in this case, this might not be necessarily the safest thing to do, but in this case, it's just going to update this very notebook that's being run. So this would be safe if you're using Git to version, your notebook, or using a copy or whatever of something that you for just testing. But so this idea is that we can try to get like some kind of direct production out of things that are typically viewed as exploratory, experimental, these notebooks, right? And again, this is using, doing the other things I talked about before. So I'm basically wrapping up here that just mentioning some other tools here that can be used to maybe do this sort of, I don't know if it's this sort of thing, but maybe I think people have talked about using notebooks to orchestrate workflows and things like that, and using it to run other notebooks. One tool I found that might be useful for helping with this is to parameterize notebooks. Basically, it's a module that you can have it point to another notebook. The basic thing it does is this cell here is a tagged cell. So I've added a tag to this cell called parameters, right? And it's going to look for a cell that's tagged as parameters. So then you can consider these default parameters. And then you can either do a command line flag, or you can pass in a dictionary that'll basically override these parameters. So you can consider, then in this case, like I said, you can consider these default parameters, and then it can go through and change some of these things, which then can get used in this script. So it's maybe a nice way to chain together scripts or have things orchestrate. So that's another, I guess, tool as far as using maybe these notebook environment sort of things for maybe production-ish sort of things. There's a thing also called NBDev that it's basically tools to facilitate making them into packaging environments, like Python packaging environment. So you can designate certain cells to be definitions and classes and things to go into the things that are going to end up in modules, right? And the tool will go through and pick these up and package those into modules. And then it'll also go through and use some of the text, I think the markdown in notebooks, and use that as automatically generate documentation for modules. So I don't know if that's I guess somewhat tangentially related to this, but again, I just put this here to let people know that there's a lot more to this delivery team story than this. Is a very small, like I mentioned, Shemek and Brian and Sri are working hard and doing and other things that are not related, less related to the data and some of this stuff. So this, we'll be adding things to this, but this will kind of be like a working document and hopefully maybe some kind of artifact that we can refer back to in general for other similar efforts, maybe. I don't know. So anyway, I'm not leaving much time if people have questions, but.
Yeah, let's say a little bit so this is, I think, one very good solution that Brian has highlighted now for data ingestion from outside. This is something that is always a challenge, and how to put it into production and how to do it efficiently. So I'm really happy to have seen what you've shown us, Brian. So why don't we take a few questions if there are any?
I have one question on the SQLite part.
Yeah.
Or I guess not a question, but maybe thought leads to some questions. I've been thinking about using this for signs in that we have these networks that we want to store. Those are multi-file networks, and they could be useful to be in a SQLite thing so that we could query sub portions of the network on the fly, which is something Chris Coleman has told me that that's what they did for SciNet. They actually use SQLite and things like that, basically to accomplish that same thing. So they could do this querying, and I thought that was it sounds like an elegant solution for signs as well for these networks. But my concern is how well it will scale in that case and the memory required to do that. And so I wonder if you have any idea of the scaling of SQLite.
The short answer is I don't know, but I think that as far as transferring data around in some ways on a continuum, I don't know. This is kind of a philosophical answer. No,
I'm not even asking for you necessarily to answer me right at the moment.
Right. No.
Just a point for discussion. I mean, I think it meets some nice needs we have for signs, but I'm worried that in general, like a lot of the files that we have that would be really large, we can write streaming processors that will limit the memory needed, process them a line at a time or things like that. Obviously, we can't do that here. And I don't know what the penalty is for having, say, a million node network embedded in SQLite. Whether it's even practical to query it on a large network. That's one part of the question. And even if we weren't doing any of the querying, because it is convenient to package all those things together as a single file, it certainly makes things nicer to move around. But in that case, what is the penalty we pay at? Presumably the penalty is in memory, at least in memory. And I'm not sure what the trade-offs are for the convenience, because it's certainly convenient.
Right. That's a thing. Yeah. I mean, this is definitely a non-disk sort of thought idea, right?
Presumably it has to get into memory. It tries to put it in memory when it actually does querying. I don't know if it keeps it all in memory.
I would hope it doesn't, but yeah, I don't know.
I mean, I don't know what it does, but I mean, a lot of the NoSQL databases and things like that, they definitely want to get the database in memory before querying, or at least the index is in memory, I should say.
Right.
So if I can comment on that, like I do not have memory comparisons for that, but a while ago I was using SQLite for something similar to query like some subset of points, and that was in tens of thousands points, not hundreds of thousands, but tens of thousands. And it was much more efficient in terms of speed and like disk space to use HDF5 for that.
Okay.
So like most commonly select operation, like the data was already stored in a way that allowed retrieval of like most common
filter,
and then like additional filtering was pretty fast because that can be relatively easy parallelized.
Yeah, I haven't compared those sorts of things as far as SQLite. I've looked at HDF5 in terms of some of the newer the formats. I've been playing with this feather file and some other things, and it seemed like it was comparison to those. It ended up being pretty big and sometimes slow, but. Yeah, this SQLite 3 might even be slower and bigger and not practical for some of this stuff. In general, right, I guess I think of databases as, in a way, an opposite end of a spectrum of things that are like compressed versus expanded for use versus compressed for transfer or whatever, right? But that's not really completely fair, because if you compare to CSV, those are all text. So that's not the most efficient way necessarily to store for use for storage and use.
I'm less concerned about storage use. I mean, within reason.
Right.
Interested in the performance and that part of it, both the use and the moving around performance, transfer performance.
I guess I was thinking in terms of whatever the structure is that ends up getting instantiated in memory, or how much of it gets in memory, if that could get big, right, or whatever.
Right.
Yeah.
Cool.
It's interesting to play with it. And it's been around a while. It's it's built. I think it's a standard library for Python, so it's handy to have it there. So.
Yeah. While we've talked about doing this I was talking about it in the context of signs, I thought of this as a general way that we could make certain types of files queryable within SciDuck. So, for example, you have a CSV file. The user wants to get a subset of that file.
Right.
We could basically automatically, on the fly, load that CSV into SQLite, cache that SQLite file, perform queries against it. Now, in the bulk of those cases, those are relatively small files, and I think that would work well, but I'm not sure how well it scales just yet. But I think it would be super cool from the, say, the file service perspective. It would be pretty straightforward to add that, because it's really just a function of the transforming capabilities that SciDuck already has for transforming between file types, and then just accepting the query and doing that.
Right. That's basically something you've designed as a pluggable sort of thing anyway, that's processing, right? So,
right.
Which is nice. Do people think this is a decent workflow strategy? Again, I think some of the stuff probably should be done with maybe SciDuck,
I don't think we push things into SciDuck just to push them into SciDuck, but I think there are certainly some useful things out here that can be used by SciDuck or just on their own. I personally want to think about it a bit more. Maybe we could continue this discussion at next week's or the week after that software team meeting. And
you touched upon many good patterns of data ingestion, Brian. I think that I agree with Dustin that I would like to think about how to fold this in. And this is again some of the construction tool that you bring to a one building project, and it's sort of standalone. So I think that is a super good analogy. I like that a lot. And many nice things there, Brian.
It might be as rickety as some of those construction trailers too.
I don't think so. I don't think no need to be humble here. I think it's good.
Yeah, I also think there are a lot of points and problems you encountered while managing the data ingestions and the constantly changing scripts around it and what is happening, and still keep it running relatively safe. A lot of strategies you came up with or applied, and which are useful in general. And I think this is the first part of a debriefing we actually need to do on what happened. And I agree with Dustin, we should talk maybe in a week or 2 weeks again about it and find out what is really working. I think the way you use the Jupyter notebook as a documentation actually of what is there. It's a self-documenting environment, which I think is needed in this prototype/production environment, because it changes, and if you have many people doing it, and if we can extend that or make that so that the next time we have a project, we don't need to reinvent all this again. So there are a lot of things learned. Clearly, your tagging by date is a smart way to avoid the date named directories, which in Git you shouldn't have them. It makes no sense. And there are a lot of other things which are great ideas, and I would like to continue the discussion on them.
Here's another thing I've been playing with too, this voila thing. Jupyter Notebook has this easy way to render notebooks. It runs all the cells, converts it to HTML and things like that. So it's another, as far as code documentation, I just thought I'd quick bring this up. It seemed kind of neat. It's relatively new. I got them to install it on Ravana. You can go through and with Ravana portal with your URL. At the end of the URL, it says lab ? If you replace that with voila, VOILA, then you'll get an HTML page that lists your file system, and you can go down into a notebook and have it render. So it's another interesting thought to maybe have things that are running, but then maybe we can, I don't know, you can run widgets. So it'll have access, the widgets will have access to the kernel that's running in the back. So it could be a thought for presentations or dashboard sort of things. I don't know how performant, but it's a relatively new thing. But I appreciate everybody's comments. Thanks.
Thank you, Brian. This was a great start, I think. I think there is a lot to be learned from this and something to carry forward.
Great. Well, thank you.
Thanks, everybody.
Sounds good. Take care, everybody.